Thank you, everybody, for coming out on this early morning. I know last night was the party, so this is always a tough one. All right, so I am here to talk about cross-scene references, a system that I made for our partners, Other Side Entertainment, down in Austin, Texas. They're working on a game called System Shock 3. So if you're watching this from YouTube, and you just want the TLDR version, there's a GitHub that has this solution already on it. If you go to Unity Technologies and look up GUID Based references, you should be able to find it. It's all really heavily commented. There's a bunch of examples. You should be able to figure out how to use it. It's basically just a way to reference a game object in one scene from a different scene without any real headache. It also includes a way of giving each game object a unique ID that you can then use for other systems. Stuff like save games. Just keep in mind, this system is efficient, but cheap is not the same as free, so cache anything you find, try to use it only where you need it. I'm going to be going into a lot of details on this, but there you go. If you're watching on YouTube, you can be done now. Great, thank you. All right, everybody's still in the room at least. So yes, if you're watching this on YouTube, now that the link is actually up there, GitHub, Unity Technologies, GUID-based references, you should be able to find it, and that should get you what you need. So, who am I? I'm Will Armstrong. I am the lead programmer on the Spotlight team in San Francisco. Spotlight is a pretty unique team inside of Unity. We've got offices all over the world: San Francisco, Seoul, Stratford-upon-Avon, and hopefully more to come if we get our headcount approved. We find the most ambitious Unity projects out there, and then we work with them to make them look good, so they in turn make us look good. We do co-marketing agreements to we write tools for them, and then they let us talk about them at things like Unite, write blog posts about it if you've ever seen any of those from us. It's a pretty cool system because there's not really money involved. Like, we choose who we work with. We find these ambitious teams. They don't pay us. They just help us make Unity better. The entire Spotlight team is made up of ex-AAA or big game developers. Myself, I was previously the lead programmer on Firewatch, and before that, I was a AAA gameplay programmer on things like BioShock 2. Speaking of shock games, the partner that we're working with for right now is Other Side Entertainment, working on System Shock 3. If you're not familiar with the System Shock series, it's one of the sort of originators of the immersive sim or ImSim genre. You play a human trapped in a decaying space station fighting a rogue alien or AI god, Shodan. There's like psychic monkeys. It's a whole thing. The games are really cool. The System Shock 3 team really helped Unity move forward in a lot of ways. We've been partnering with them for a couple years now. They were one of the first teams on HDRP before it was publicly available, definitely before it was production ready, and helped us really iron out a lot of rough edges from that system and prove that what we were trying to do with the scriptable render pipeline was the right move. We made decals for them. If you've used the deferred decals, that was Paul Melamed from the Spotlight team, did that for them. And he's currently working on a way to do culling with sectors and portals. System Shock is all set in a space station, so it makes a lot of sense to choose how to cull things based on rooms and doors. There's a lot of those in a space station. And then the crossing reference solution that I'm talking about now was made specifically for them, because they have a ton of scenes. So the problem that this is trying to solve is that as a team scales up, the number of scenes explodes dramatically that you need in Unity. So if you're going to ship on console, you have a fixed memory size. And if your level doesn't fit in that fixed memory size by default, you have to split it up. We did this even on Firewatch before there was like multi-scene editing. Now that Unity supports multi-scene editing natively, this is a lot easier to do. So you take your game and you split it up into areas that'll fit easily in memory. You load some subset of them, and as you move around the world, You load up the scenes in front of you, you unload the scenes behind you, and that's kind of how you do streaming in Unity today, is load scene, additive async, unload scenes when you're done, move around the world, easy peasy. Once you have a large team, though, now you need to break up your scenes by discipline as well. As I'm sure lots of you know, scene files don't merge particularly well. A lot of time, most of our clients actually lock scene files when somebody is editing them. We do have things like smart merge. You can use text merge on the YAML. It's all doable, but it's very difficult and fraught with peril. So we recommend that most teams just lock the files. When you have a AAA team, you're not going to have like everybody wearing multiple hats. In indie dev, it's very common for one dev to go in and like do a whole area of the game by themselves. On a AAA team, you have a level designer, a level architect, a sound guy, a lighting person. Every person on the team is going to be specialized for their particular role. And that means that they're going to need to be working at the same time in the same area of the game, and they can't work in the same scene. So you then layer those physical scenes where you're streaming your memory for like level design, level art, sound. You then immediately have to be able to reference game objects across those scene boundaries. If you want to make a key that you can pick up that unlocks a specific door, the level designer is going to be the person that makes that key. The level architect is going to be the person that makes that door. They're going to be in different scene files, and you need to be able to talk to them. It's just absolutely required that you have some way of reasoning about cross-scene content. On Firewatch, we did this with a lot of like playmaker scripts and managers that were just registering stuff and event systems that were all string-based. It was very ad hoc. We didn't have a good kind of unified way of doing that. So for our big AAA partners, I knew that we had to come up with something better. So to give you a sense of the scale of the problem here, and now I'm going the wrong direction. This is me just hitting play on the main menu of System Shock 3 and tracking how many scenes are loaded. You can see that we start out with like a bootstrap scene and a start menu scene. We start loading things up. You can see that's the hangar. The Gamescom demo that they just made was all in a big hangar inside the space station. And you've got like static and dynamic art levels. You've got design levels based on different types of objects. You've got audio levels in here, and it just goes and goes and goes and goes and goes. All right, I think maybe it's done. Nope. All right, well, we're seeing some content. That's a good sign. Maybe everything's fit. Nope. No, there's still some more. So a lot of scenes. And this is just one part of the game. This isn't even like a whole level. This is one demo for Gamescom. All right, so hopefully I've convinced you that you need to be able to reference game objects across scenes, but I don't know, there's a checkbox in the editor if you've ever found it that says enable cross-scene references. So maybe you're thinking, okay, we'll just check that, done, easy. Problem is that doesn't actually work. Those cross-scene references won't survive a build. And you're like, well, maybe there's something else you can do. Maybe you've looked in the YAML file for a scene. We have as you can see here, we have a bunch of like things that look kind of like they could be GUIDs. We've got file IDs. We've got something that is a GUID, which is a global unique identifier. We've got some instance IDs in there and some offsets. This all sounds like stuff that could be used to do this, a way to identify a game object in another scene. Unfortunately, for performance reasons, when we make a build, we go through and we pack all of these instance IDs into a flat linear array. Instead of looking up game object 16,514 or whatever, it's just going to say, all right, this is the first game object in the scene file, so now it's game object 0. There's no real way to store out that mapping. There's no place in Unity's build system where there's a clear, like, hey, here's where we remap all of these game objects. It's done all over the code base. I spent about 3 months trying to, like, just make this part of Unity and build in a nice stable ID. It's just not possible the way that Unity builds its content right now. it's too important for things to be linearized for that fast access in an actual build. So if you try to use any of the ideas that we have built in, you'll find that in your standalone build, your crossing references just fail. We need something more stable. We need a way to identify a game object in a way that's never going to change. That once we've created it, it's going to be perfectly rock solid. So stable that I could like write it down on a piece of paper and punch it back in like a save game from Mega Man 2, if anybody remembers that. So C# actually gives us a way to do this. System.GUID. Great, cool. Guaranteed unique. I can write it down, it's fine, it's not going to change. If I can just figure out how to make that stable, it should be good. It's, you know, guaranteed unique within like the heat death of the universe, so probably fine for our purposes. And then I could, you know, okay, once I've got a unique ID, this should be pretty easy, right? I just like throw all those IDs in a dictionary, match them to my game objects, I can look them up later. Great, easy peasy. So I tried to do exactly that, and just made the simplest version of this tool possible. Here's, you know, sort of an example of the workflow. You can see I've got a couple of game object references there, something called a crossing reference. If I try to drag something from another scene, it doesn't work. It's very frustrating. Like, oh, okay, well, what have I forgotten? If I then go over and add something called a GUID component, that's going to give me that unique ID. That's going to then enable me to drag that, drag the reference to my little spinning cylinder here over to my test content. Then I've got one scene. I load up a second one that just has the little capsule in there, and then it and the thing that referenced it both spin. It manages to find that across the scene boundary. You'll note that I used HDRP here so that we get the prettiest spinning cubes possible. All right, so this is my keep it simple, stupid solution. Let me apologize ahead of time for the coding standards on these slides. Posting code into a slide, you don't have a lot of room, so I had to like call out all the comments and all the nice friendly white space and just leave the most important bits of code. If you go look at the GitHub, you'll see that all of this code is very, very thoroughly commented, explains what it's trying to do and why I'm trying to do it. But in this case, I'm here in the room, so I can take the place of my comments. This is the core of the system. This is that unique ID. This is what makes everything else possible. I've cut out all the awake boilerplate, but really all this is doing is making sure that we have a GUID, that unique ID, and then registering it with a manager. This is also where we handle one of the two failure modes of generating a unique ID. The first one is on generation, making sure that you actually have something unique. That's easily solved with C# system.GUID, as long as you make sure that all of your tooling doesn't allow you to do things like copy and paste and duplicate. And I'm going to go into all of the editor work that I had to do to make that possible in a minute. But the problem is that if you have a GUID collision, you have to have some way of handling it. There's no way to prevent users from just like going in and copy and pasting YAML. Like if you wanted to, you could go into a prefab that had a GUID component, copy the actual GUID value and paste it in somewhere else, and I now have a collision. We have to be able to deal with that. So if you look here, you can see when I try to actually add this GUID component to the GUID manager, it returns a Boolean, just a failure, false if it didn't manage to work. And if that happens, the GUID manager logs about it, and then this system just says, fine, whatever, I'm making a new one. That at least keeps every runtime system that might need these IDs functioning. So you're still, the second you add a GUID component, you're saying, I want this game object to have a unique ID. If you have any systems like save game, if you have any systems that are caching off those unique IDs as it runs, this will keep those functioning. Any baked out GUID references will break at that point, but you've done something wrong, you've horribly broken the system, you've managed to get two doors with the same ID, the key's gonna unlock both of them, or it's gonna unlock one of them. There's really no way around that. You've managed to violate the uniqueness. The GUID manager itself is really, really simple. It's a traditional singleton. It's not a game object. It's not a mono behavior. It's lazily created the first time something needs it. This keeps the setup for this as simple as possible. You don't have to worry about, oh, did I forget to add a GUID manager to my main menu? Did I forget to add one to my save game? It just handles it for you. The one thing to be aware of, this can, in principle, leak the GUID manager instance. Anytime you're dealing with singletons, this is a bit of a problem. In this case, almost every game, if you need unique IDs, you need them for the length of the game. And it's not really gonna come up where you need multiple of them, or there's a big chunk of the game where you don't need them. Once you create one, you're never gonna get another one. It should be fine. If, however, in your project, and you want to use cross-scene references, but you have a use case where unique IDs are only needed for a tiny subsection of the game, you could easily wrap this in a game object, in a mono behavior, and control the lifetime yourself, or remove the automatic instantiation and just handle it explicitly. This is really just a dictionary. Like, honestly, this is just a wrapper around a dictionary from those system GUIDs to game objects with a tiny bit of fanciness. Rather than just go directly to the game object, I go to something, we created a GUID info. What it does is it gives you a couple of callbacks using actions. These callbacks get called every time a new GUID component registers with the system or unregisters with the system. This is really important because it gives you a very clear way and very clear place to cache anything that you need. Since these cross-scene references, there's no guarantee on when that scene is loaded. It's very easy to end up accidentally writing code that's like polling for the existence of your cross-scene game object. You know, you've got your key that's looking for the door to unlock in every frame. It's like, hey, does that door exist? Does that door exist? Does that door exist? That's really not a great pattern. That's going to cause a lot of dictionary lookups. It's potentially whatever other code you're running there will run a lot. Instead, you can just put all of that into one of these, the on-added callback, do whatever work you need to do, set up anything you need to set up, and then you have a nice on-removed callback for if somebody unloads the scene, you can remove anything you've cached. It lets you write really, really performant code around this. And then this is the custom component this is the custom class that lets you drag the game object from one scene to another. This is sort of the referencer, GUID reference. The only reason it's a class is I need this serialization callback receiver. Unity's serialization system only understands a very small subset of types. System.GUID is not one of those types. It has no idea how to do that. So I need this iSerialization callback receiver so that anytime I'm writing to disk or reading from disk, I can take a format that Unity's serialization system can understand and convert it back and forth to that system.GUID. Originally, I used strings. I figured those were, nice and human readable-ish. Turns out that that's about an order of magnitude slower than just using a byte array. C# system.GUID is just much, much faster with byte arrays, doesn't allocate any memory. If you find yourself messing with them, highly recommend that instead. The other thing that this handles is automatically caching the game object reference itself. If you look at this game object accessor, that is handling looking up from the dictionary, and if it finds a game object loaded, which again, because it's in another scene, who knows if it is loaded or not, the first time you call it and it is loaded, you'll cache it forever, and from then on, it is just a dereference. This is keeping the solution as quick as possible. Once all your scenes are loaded, it should really just work like any other game object reference that you've ever made. If you're writing simple gameplay code where all you're doing is grabbing the game object in the other scene, like moving it around or something like that, that's all, you just need the transform, you can really treat this code as though you didn't care where that scene was, and there's not really a problem with using GUID references inside the same scene. You're not paying a lot of extra. Paying a little extra, though, so don't just go completely hog wild. So the limitations of this system, it's very, very simple, which is nice, but it only lets you reference game objects, which is a pretty big limitation. There's a lot of times that's not what you're actually after. If you want to be able to reference one thing from other scenes, you have to go into that other scene and add a GUID component. This means you have to think about things ahead of time a little. And then cheap does not equal free. So I'm already caching the game object lookup. Dictionary lookups are relatively affordable. There's not any like update code. I've got nice callbacks to make this more efficient still. But none of that is free. This is never going to be as cheap as just having a direct reference to exactly the component you need. So if you can get away with just having direct references and you can guarantee that you're inside the scene, or you can pack everything together in the same prefab or use nested prefabs, it is always better to do things the nice, clean, native way. The benefits of keeping this system so simple is that it's just super easy to drop into anybody's package. I actually found out that this week I found out that 2 more of our clients have been using this solution this whole time and just never had any problems and never brought it up and never mentioned it. They're like, oh, yeah, we use that. It works great. I'm like, oh, sweet, excellent. So it's just dead simple. And that's kind of what I like from all gameplay code and all gameplay tools. If you explain how your tool works to somebody and they don't get it, you're probably in a bad place. If, however, you explain how your tool works and everybody goes, oh, that's so simple, well, that's trivial, of course that's how you would do it. That doesn't mean you came up with something stupid. That means you did the work that people weren't willing to do, but it makes sense and everybody's just like, oh yeah, okay, I get it. Keeping things simple like this also means that everything just works nicely with Unity. Like, I'm not trying to reinvent the wheel here. I'm not doing anything super clever or tricky. I'm not building really customized workflows here. It all just pretends like you can just drag game objects around between scenes, and that's how it always worked. So, when I talk about making tools for clients, back in the day, that was my team. Now it's other game teams spread all over the world, but we kind of all look for the same attributes for what we consider a quality tool in Spotlight. First of all, we want everything to kind of have no surprises. Everything should just work like you expect it to. On your teams, in your projects, when you build a tool with your own team, you can sort of layer on complexity as you go, and you can build a shared language and a shared workflow that works exactly for your artists, exactly for your designers. And you can make really complicated tools that work perfectly for your team. You know, when you're coming in from an outside place, like we do, when you're an outside consultant and you're just dropping a tool into an existing production, you don't have that nice slow ramp. So we want everything to just sort of work like you would expect. Any tools we write, anything we write really, has to be performant by default. And I don't mean that quite in the same way that Joachim means it. What I mean is that what that means for gameplay code, what that means for stuff that we're adding to existing systems, is that everything can have a cost when you use it, and that cost is allowed to scale at worst linearly with the amount of content you throw at it. We are not willing to accept anything that just sits there and does stuff by existing. We almost never use update functions. We almost never use like late update, on collision received, on collision trigger, any of those mono-behavior functions. We actually mostly avoid using mono-behaviors when we can. We've been doing data-oriented design for quite some time. And this is an example of that. We really want things to just be fast if you don't touch them. And then nothing should do anything at all when it's disabled or deactivated. We cache everything we can so that you only pay the cost once if you do use it. There are a lot of things inside of games and inside of Unity that scale weirdly. You know, you're like, oh, I threw 10 of an object into the game and it was fine. I threw 100 in and suddenly it's slow and I don't know where that performance went from. or I'm not doing anything with any of this content. How is it possibly slow? It's all disabled. And then the big one is everything we do for Unity has to be completely garbage-free. We do not consider it acceptable to allocate any memory at any time other than loading, period. And we constantly add tests to other parts of Unity to make that true. Like, one of the big things that we did with the System Shock team and their early use of HDRP was just go through and eliminate every single per-frame allocation we could find. We were always on it. If you've ever worked with Unity, if you've ever made a Unity project of scale, I am sure you are familiar with the garbage collection spikes that can come from garbage. We know how easy it is to write gameplay code that just allocates all over the place. We really don't want to add to the problems you already have. We understand your pain. One of the big things we do on the Spotlight team is go in and fix up other people's garbage collection issues. Speaking of which, a little simple aside, quick aside here. Before I even got this project out the door, so we made this very simple crossing reference solution. It was all more or less working. I wrote some performance tests. I love performance tests. If you've never used the Unity test runner, I highly recommend checking it out. We've got a really nice suite of tools to make it very easy to add tests both in runtime and editor time. They're easy to add. We have a test runner integrated into the editor. You can just bring it up from window test runner and help make your tools more solid, help make your gameplay systems more solid. The first time I wrote a scaling test for this system, turns out that actions actually allocate memory if you use them like you would expect to. Namely, if you ever use an anonymous delegate in an action, it does a boxing allocation. And it can really add up. So I was registering like 10,000 of these GUID callbacks. That was allocating a meg of memory every frame that test was running. The acceptable amount of memory to allocate is 0, literally 0, so I was way off. However, there's a really easy fix for it, which is awesome. So if you're using actions in your own game, just be very aware of this. If you look at that resolve GUID line towards the end of the function, you can see that I'm passing in private member variable versions of my GUID added and GUID removed delegates. Originally, I was just calling those as anonymous functions. That's where that boxing occurred. So I was boxing 2 callbacks every time I registered one of these, and that's how you get to a meg with 10,000 of these registrations going on. All right, so that's how you fix the sort of garbage-free problems and the performance by default problems. You write performance tests, you write scaling tests. But no surprises is a little bit more of a subtle way of thinking about tools. So what I mean by no surprises is, if you're familiar with software design, this is like principle of least surprise or principle of least astonishment. You really want every tool you write, every editor you write inside of Unity to work as the user expects. But expectation is a tricky thing. If you're working with your team, you can set those expectations. You can, like I said, build a shared language. We don't have that luxury. So we really have to keep things working like Unity as much as possible. Anytime we write a custom tool, we want it to just behave like it's the larger Unity ecosystem. Since we are Unity, even though we are working very closely with these teams and we are mostly working in user code, we still find that we get the best results by sticking to Unity standards, even when those standards aren't what we would necessarily want. So I'm going to do a little bit of a deep dive into the tool I wrote around GUID references here. And so this is a close-up of the workflow I showed earlier. You can see that I've got this cross-scene reference field there, and all that is just a public GUID reference. It's used exactly like you would add a public game object to any other script that you might write. And it shows up as though it were just like a GUID component, as though it were a public GUID component field. You can use the picker just like anything else. It shows the name of the game object it's attached to. You can drag and drop with it. The only difference between this and just any public game object field that you might write is it just magically seems to work when you drag it across scenes. That gives you the most discoverability, the most clarity that you can really have. It also, by using just the basic like ping system here, by using the basic like object reference system, you still get like pings, you still get all the niceness that you would expect. The one thing I really had to add, did I skip a scene here? Yeah, so if you unload the scene, this looks a little bit different. You can see that I've got the field grayed out. We use that all over Unity. That's the sort of you can't edit this affordance that we have. The reason for that is if you have a reference to a game object that's in a scene that's not loaded, if I then go into the game object selector, the basic Unity one, there's no way that I can select my previous game object without it existing. So the first version of this tried to work exactly like Unity by default, and we ran into a place where the UI was nicely consistent, but the user experience was wildly inconsistent and really surprising. If you unloaded the scene and then tried to edit what your GUID reference was pointing to, your only option was to pick a new object or clear out the old one. So instead, I made the field completely non-editable, and added an explicit clear button. While that's not how the rest of Unity looks to work, it is how the rest of Unity does function. So it keeps the workflow the same, even if I had to tweak the UI a little bit. So when I say stick to Unity standards, I don't mean like dogmatically. Try to work the same way that Unity works and respect user intention. The other thing I added to every one of these cross-scene references is the containing scene field. This is a non-editable field, just like the previous one, but it is a disabled asset picker, and that lets you use the like ping stuff that we've already got. It lets you click on that scene and then load up, right-click, load that scene from the project view. At first, I actually added a load scene button. And the problem is on a big game, load scene is a major operation, like load scene additive in editor. That can bring your editor performance to a crawl. So it's kind of a trap button. If you're dealing with scenes that are very, very large, and you already have a bunch of stuff loaded, loading up other scenes on top of that will very quickly just tank editor performance. So giving users a shortcut in this case made it very easy to kind of degrade your own Unity editor performance. And it turned out to be a better call just to let it work like any other scene reference. Don't get too clever. All right, and this is the custom property drawer that I made for that GUID reference. This is how that all works. You can see that I've got this like GUI.enabled false, and then I make the object field and then turn the GUI enabled back on. That's how you make those sort of non-editable fields if you ever need those for information. You can see I do some work here for like getting serialized objects from an array, which can be quite tricky. This custom property drawer has a lot of good examples in it on GitHub. A lot of comments, kind of tells you what every section of it does. I find these days that I'm actually writing custom property drawers for almost every class, serializable class that I write. If you just get into the habit of when you make a new type of gameplay data, just throwing in a custom property drawer for it, even if all it does is call like the default inspector, later on, when you find places that you want to edit it, you can just jump into that existing C# script, write whatever custom editor you want, and keep on with your day. I find that it makes my workflow way more efficient. It makes me way more willing to just edit this stuff. Because if you have that moment where you're like, all right, I need to add a custom property drawer to this. I want to add some extra data. Let's just say like debug data, like this scene reference. This isn't needed. The runtime doesn't care about that. Only the editor needs to know what scene your game object is from. If, by loading that, keeping that data in editor only, I make the runtime data simpler, but if I didn't have this custom property drawer already created, it would be very, very tempting to just throw it into the runtime data real quick rather than go in and like add another new class and throw it into a new editor folder and have to do all that boilerplate. So just make it part of your workflow to create these by default, and I think you'll find that you end up with in a much better place. It gives you nice separation of concerns, and you can then customize your edit time data for being human readable and human friendly and keep your runtime data as lean as possible and as perfect as possible for your actual game. You're going to see that pattern a lot in Unity as the days go forward. That's really the sort of underlying reasoning behind all of our ECS conversion workflows, where we keep editor data in one place, runtime data in another. All right, great. So I've got a custom property drawer that's doing all of this nice work. I've got this system that lets you do crossing references. So I give it to the System Shock team. And yeah, one of their giant robots just kind of starts blowing it up. They found a bunch of bugs. Great, fine. There's some null references. I fixed those. That's all in the GitHub. They immediately wanted to add GUID references to everything. They were like, oh, I don't want to have to think about it ahead of time, so I'm just going to add GUID references to like every prefab and then nest those prefabs and make prefab variants, all with GUIDs saved into the prefabs. Like, oh no, that's not great. I actually I kind of wanted to add a lazy adding of the GUID component. So you drag a game object into the GUID reference and it just adds a GUID component if you need it, so you don't have to think about it ahead of time. We tried that. Problem is that because scenes are lockable, if I drag a game object from a scene that somebody else has checked out, drag it in there, and it doesn't have a GUID reference, there's no way for me to add it. I can't check that scene file out. I can't then edit it. So it doesn't actually scale for the sorts of workflows that I'm trying to solve with System Shock. This is why it's so important to test at scale on real productions. And they wanted a couple of changes to the API. The changes that they wanted were very custom for the game. I made them no problem, added them to their Perforce, and that had never made it back up to the GitHub. That's actually why I like keeping these kinds of tools as source code that you add to your project, so you're free to customize them however you want. They had a very specific use case where they needed to mess with the on-added and on-removed callbacks when a GUID component got added for the specifics of their AI system. The reason that we like giving these tools to clients before anybody else is this immediately maps to improvements to the ecosystem before it goes large for everybody. I found all those null reference cases, I improved the stability, I had some ideas for future features, was able to test them out, decide they didn't really work. And it showed us the problems with scaling. So talking about adding GUIDs to all those different prefabs, it really didn't matter. Like, those GUIDs were getting created in the instances in the scene data just fine, and they were absolutely stable. Once you made an ID, it was perfect. The GUID never would pollute from the prefab or the prefab variant into the scene, but it meant that you were just constantly checking out these prefabs. Like, Perforce was like, oh, you changed something, and you just changed a magic number in the file. Artists and designers are looking at it and going, what did I do? And once you have a confusing behavior, like a little bit of a surprise, trust in the tool goes down immediately. And the team is like, oh, I never understand why Perforce isn't working right. I don't trust Unity anymore. And that's a real problem for us. So working with a team like System Shock, we really have to nail this stuff down. And this is how you detect the case of, hey, I'm actually inside of a prefab being edited in a prefab stage. All of this code was originally made back in 2017, before we had all the nested prefab work in. System Shock was one of the early adopters of the nested prefabs as well. But as the nested prefab solution rolled into Unity slowly, I was having to constantly change this system to make it keep working. The tricky thing here is that there's this like stage utility get mage stage handle and the prefab stage utility get prefab stage. That'll let you, by comparing those things, you can then figure out, hey, I'm a prefab that's being edited in the prefab editor right now, so I'm no longer an asset on disk. I no longer obviously appear like a prefab, and the normal checks won't succeed. For your code, hopefully, you never have to worry about this. Normally, I would just say use the undo system. The undo system figures all of this out for you and will do all of the prefab dirtying and make sure that nothing gets written to there that it doesn't need. In this case, you can't really undo creating a GUID. Like, you have to have one, so if you undo it, it's just gonna make a new one for you. That's not meaningful. If you do find yourself in a similar case where you really need to know if you're editing a prefab or not, this is how you do it. And we can then detect that and just not write a GUID out and just leave it blank. It's not an instance, doesn't have one. Once we did all of this work to make these IDs rock solid and rock stable, we got a big win out of it. System Shock 3 is, like every other immersive sim, has a lot of environmental interactions, a lot of AI running around. You end up with a very complicated save game system. A save game system is really just like a way to identify a game object and then a store of the persistent data that you need for that object. I've already solved half of that with this system. These GUID references are rock solid, the GUID component. So if you can just make a little component that stores all of the save data you need for any given like AI or whatever, you add that to anything you need in your game, have it require a component on GUID component, and then you get your stable ID guaranteed, and you're done. Like, it ended up being a really nice win for us where we could take, half the work of save game off the team. All right, so that's my GUID reference, stable ID, cross-scene reference stuff. I want to, by keeping all of this work in GitHub this whole time, partnering with the team really early and iterating with them a lot, we ended up with a very, very simple code base, a very simple, robust solution that was a lot more streamlined than anything we had tried to come up with for when we were trying to figure out how to add this to Unity as a whole. The real-world at-scale testing helped us make the best tool possible. Like, this is pretty efficient, this is pretty fast, doesn't take a lot of extra memory, doesn't take a lot of extra performance. And I really want to thank the team at Other Side Entertainment for letting me talk about what we worked with together, and for being the guinea pig for all of these very early releases that we made, kind of put them through. If you want to go take a look at what the System Shock 3 team is up to, they just released a Gamescom trailer, which is excellent. It's a really great example of like what a bunch of sort of AAA console artists can do given HDRP. We're also always looking out for the next sort of great spotlight project. My contact information is up there. Don't hesitate to reach out if you think you are on the absolute forefront of what a Unity game can be and would like some help, some feedback, some assistance, just some marketing support. And don't forget to fill out your questionnaire on the little Unite app. So, does anybody have any questions, suggestions? I'm actually trying to finish up this crossing reference solution and kind of package it up nicely before stopping active development on it. So now is the time for feedback if you found this earlier and managed to use it yourself.
Hi. Is it possible to override the GUI ID so that we can, for example, for a given cross-reference, say this GUI ID is going to be now a number that I decide?
You cannot in the basic API. It would be very easy to make that public or to add a setter to it. We actually did have to add a accessor to the solution that we gave to the System Shock team so that they could tell whether or not a GUID reference was actually set or not. You can also look at the number if you ever need to, just by going into debug mode on the inspector. We don't let you change it because once an ID is locked, any references that are made to it, if you change the ID, those references are going to be invalid, and there's not an easy way to track those back down without loading every scene in your game.
So it's still better to have a lookup table for that.
Yes.
If we have an ID, we just connect it like that with a lookup.
Yes.
Okay, thank you.
Looks like we're just about at a little over time, so if anybody has any other questions, I'll be right out in the breakout room in just a second. Thank you all very much for coming out.